The camera is descending into darkness. 2,000 feet below the surface of the Pacific Ocean, sunlight has become a memory. The only illumination comes from the camera's faint glow, cutting through water so deep that the pressure would crush a human body instantly. Then something appears at the edge of the frame. An arm. But calling it an arm doesn't capture the reality of what's moving through the water. It's 20 feet long, thick as a telephone pole at the base, lined with suckers the size of dinner plates. And those suckers aren't smooth. Each one is ringed with sharp serrated teeth designed to grip prey that's trying desperately to escape. The arm extends further into the light. Then another arm appears. And another, 8 arms in total, each one longer than most sharks, all converging toward a central point where a body the size of a minivan hangs suspended in the black water. This is Architeuthis dux, the giant squid, the creature that inspired 1,000 monster stories, the animal that sailors swore could drag entire ships beneath the waves, the beast that science insisted was myth, right up until the moment a fishing boat hauled one up from the depths in 1873 and proved that sometimes the monsters are real. For over a century, the giant squid existed in that strange space between legend and reality. We knew they existed because we found their bodies, washed up on beaches or floating dead in shipping lanes. But we had never seen one alive in its natural habitat, never watched it hunt, never observed how it moved through the deep ocean where it actually lives. Every attempt to film one failed. Submarines descended into the abyss and found nothing. Remotely operated vehicles searched for years without success. The giant squid remained a ghost, something that left evidence of its existence, but refused to be witnessed. Until 2012, when a team of Japanese researchers finally captured the first footage of a living giant squid in its deep ocean habitat. And what they saw revealed something terrifying. The giant squid isn't just large. It's not just another big animal living in the deep sea. It's an apex predator engineered by evolution to hunt in an environment so hostile that almost nothing else can survive there, using biological weapons so sophisticated they seem designed by nightmare. So what makes the giant squid the true monster of the deep? What adaptations allow it to dominate the darkest parts of the ocean? And why is this creature, more than any other deep sea animal, the one that actually deserves the title of monster? Because once you understand what the giant squid is really capable of, once you see the hunting tools evolution gave it and the extreme environment it conquered, you'll realize that the old sailors weren't exaggerating. They were just the only ones who lived long enough to tell the truth. A sperm whale is diving. It needs to eat, and the only food available at this depth is squid. Small squid, medium squid, and if it's lucky, something much larger. The whale descends past 1,000 feet, then 2,000 feet. The water pressure is now crushing, over 1,000 pounds per square inch, enough to collapse human lungs like paper bags. The temperature has dropped to just above freezing. The darkness is absolute, a blackness so complete that light itself seems to have been erased from existence. This is the mesopelagic zone, the realm where the giant squid lives, and the sperm whale is about to discover why hunting here is so dangerous. Something strikes the whale from below. Not a bite, not a ram, but a grab. 2 arms, each one over 30 feet long, wrap around the whale's body with crushing force. The suckers on those arms lock onto the whale's skin, and those serrated teeth dig in, creating hundreds of circular wounds that immediately start bleeding. The whale thrashes, trying to shake off its attacker. But the giant squid doesn't let go. It brings more arms into play, wrapping the whale in a cage of muscle and sucker-lined limbs. Then it does something that reveals just how dangerous these creatures really are. It pulls itself toward the whale's head, extending 2 additional appendages that aren't arms at all. They're tentacles, specialized hunting limbs that have been coiled up inside the squid's body, waiting for exactly this moment. These tentacles are different from the 8 arms. They're longer, thinner, more flexible, and at their tips, they expand into broad clubs covered with the largest suckers on the squid's body, some of them 4 inches across, each one equipped with those rings of sharp teeth. The tentacles shoot forward with explosive speed, striking the whale's head, the clubs wrapping around whatever they can reach. The giant squid is now anchored to the whale with 10 limbs, using every biological tool it has to control a predator that outweighs it by 20 tons. This is the part that terrifies marine biologists. Because the giant squid isn't trying to kill the whale through constriction or drowning. It's trying to position itself correctly to use the one weapon that can actually damage something as massive as a sperm whale: its beak. At the center of all those arms and tentacles, hidden in a mass of muscle called the buccal mass, sits a structure that looks exactly like a parrot's beak. It's made of chitin, the same material as insect exoskeletons, but compressed and hardened into something sharper than most metals. The edges are razor sharp. The point is designed to pierce flesh, and the muscles that operate it can generate over 1,000 pounds of bite force. The giant squid maneuvers its beak toward the whale's skin and bites down. The beak punches through blubber that would stop most predators cold, cutting deep into the tissue underneath. The squid bites again and again. Each bite tears out chunks of flesh, creating wounds that weaken the whale, cause bleeding, create pain that might force the whale to retreat. Most of the time, the whale wins these encounters. Sperm whales have evolved specifically to hunt giant squid, developing echolocation sophisticated enough to find them in total darkness, teeth designed to grip slippery prey, and enough mass to overpower even the largest squid. But not always. Researchers have found dead sperm whales with giant squid beaks lodged in their flesh, wounds that became infected and killed the whale days or weeks after the fight. They found whales with scars covering their heads and bodies, circular marks from squid suckers, evidence of battles that went on long enough to leave permanent damage. And they've found squid beaks in whale stomachs that are so large they could only have come from animals over 50 feet long, giants so massive they push the limits of what we think is biologically possible. This is what makes the giant squid a true monster. It's not the biggest animal in the ocean, it's not even the biggest squid. That title belongs to the colossal squid, which is heavier though not longer, but it's the one that can fight back against apex predators, that can inflict serious damage on animals that should be able to kill it easily. And it does this using biological weapons that are perfectly evolved for hunting in an environment where most animals would die within minutes. The giant squid's tentacles are engineering marvels that shouldn't be possible. Each tentacle can extend to over 35 feet long, roughly 3 times the length of the squid's body. They're muscular, flexible, and capable of moving independently with precision that seems impossible for something that's essentially a boneless limb. But here's what makes them truly remarkable as hunting weapons. They can shoot forward at speeds approaching 25 miles per hour. Think about the physics of that. The tentacles are normally coiled inside the squid's body, held in a contracted state by muscle tension. When the squid attacks, it releases that tension all at once, and the tentacles snap forward like biological harpoons. The acceleration is instantaneous. One moment the tentacles are tucked away. The next moment they've extended to full length and wrapped around prey that didn't even see them coming. This strike speed is crucial for hunting in the deep ocean, because down in the darkness, most prey animals have evolved to detect predators through water disturbance, pressure waves created by movement. A slow approach gets detected. The prey escapes. You starve, but a strike faster than the prey's reaction time? That's how you eat. And once those tentacles make contact, escape becomes nearly impossible, because the clubs at the tentacle tips aren't just covered with suckers. They're covered with the most sophisticated biological gripping system ever evolved. Each sucker is a muscular cup that can create negative pressure, essentially a biological vacuum that pulls the sucker tight against whatever it's touching. In water, this creates an incredibly strong grip, strong enough that you can't pull a squid sucker off a surface by force. You have to break the seal by sliding something thin underneath it. But the giant squid suckers add another layer of horror. Those rings of teeth, some of them sharp and pointing inward, some of them blunt and designed for crushing, don't just help with grip. They cut into the prey's flesh, creating wounds that make bleeding and struggling more difficult. Researchers who've examined these suckers under microscopes describe them as almost mechanical in their precision. The teeth are arranged in specific patterns, different configurations for different parts of the tentacle club, as if evolution designed each sucker for a specific purpose. The suckers near the tip of the club have sharp inward-pointing teeth designed to pierce and hold fast to slippery prey. The suckers closer to the base have blunter teeth arranged in crushing patterns, designed to damage prey that's already caught and trying to fight free. It's a graded weapon system. The initial strike uses piercing grips to catch. The sustained hold uses crushing grips to control, and all of it happens in total darkness, at depths where the water pressure would kill most animals, at temperatures just above freezing. This is adaptation to an extreme environment pushed to its absolute limit. The giant squid has evolved hunting tools so effective that it can catch prey moving through three-dimensional space in complete darkness. Hold onto that prey despite the low temperature making muscle function difficult, and do enough damage to kill or disable animals that are fighting for their lives. But the tentacles are just the beginning. Because once the giant squid has caught something, once those tentacles have wrapped around prey and those suckers have locked on, the squid needs to do something even more difficult. It needs to eat. And eating in the deep ocean requires solving a problem that almost seems impossible. The giant squid has that parrot-like beak hidden at the center of its arms. But unlike a parrot, which has a skull and jaw to anchor its beak muscles, the giant squid is almost entirely soft-bodied. There's no skeleton, no hard structure to brace against. So how do you generate enough bite force to cut through flesh when you have nothing rigid to anchor your muscles to? The answer is one of the most bizarre anatomical structures in nature, the buccal mass. Imagine a ball of muscle the size of a basketball, packed so densely that it's almost as hard as bone. This mass sits at the center of the squid's arm crown, and it serves as a pseudoskeleton, a structure rigid enough through pure muscle density that other muscles can pull against it. The beak itself is embedded in the front of this mass, held in place by more muscle and connective tissue. When the squid bites, muscles running through the buccal mass contract, pulling the two halves of the beak together like scissors, closing. But here's the really strange part. The beak isn't uniform in hardness. The tip, the part that does the actual cutting, is incredibly hard, harder than almost any biological material except teeth. But the base of the beak, where it connects to the soft tissue of the buccal mass, is much softer, almost flexible. This gradient from hard to soft prevents a critical problem. If the beak was uniformly hard all the way to its base, the junction between beak and soft tissue would be a weak point, a place where stress would concentrate and cause tearing or damage. But by gradually transitioning from hard to soft, the squid distributes stress across a larger area, preventing injury to its own body when it bites down with full force. This is material science at a level that human engineers are still trying to replicate. We can't make materials that transition smoothly from rigid to flexible while maintaining structural integrity. But the giant squid grows one naturally, using nothing but proteins and chitin arranged in gradually changing densities. And that beak needs to be this sophisticated because of what the giant squid eats. This isn't an animal that feeds on soft-bodied jellyfish or tiny zooplankton. It's hunting fish, hunting other squid, hunting anything with muscle and flesh, and enough nutrition to justify the energy cost of a hunt. That means cutting through scales, through skin, through muscle tissue that's fighting back. The beak has to be sharp enough to pierce, strong enough to cut without breaking, and it has to work in an environment where everything is cold and pressure is crushing, and it does. Researchers examining the stomach contents of dead giant squid have found partially digested fish, smaller squid, and in some cases pieces of prey so large they suggest the squid attacked animals nearly as big as itself. This is apex predator behavior. This is an animal confident enough in its weapons that it's willing to attack dangerous prey, willing to risk injury because its tools are good enough to win the fight more often than not. But all of these weapons, the explosive tentacles, the gripping suckers with the rings of teeth, the razor-sharp beak backed by a ball of solid muscle, none of them would matter if the giant squid couldn't solve the most fundamental problem of living in the deep ocean. How do you find prey in absolute darkness? The giant squid has the largest eyes of any animal on Earth. Each eye is the size of a dinner plate, nearly 11 inches in diameter, roughly the size of a basketball when you include the supporting tissue around it. These eyes are not just scaled-up versions of normal eyes. Their specialized organs evolved specifically for detecting the faintest traces of light in an environment where no light should exist. At 2,000 feet deep, sunlight is completely gone. The ocean is pitch black, but bioluminescence, light produced by living organisms, still exists. Deep sea fish create flashes of light to communicate or confuse predators. Jellyfish glow as they move. Even the disturbance of water by a swimming animal can trigger bioluminescence in microscopic plankton. These light sources are incredibly faint. A momentary flash in the distance. A brief glow that lasts for a fraction of a second. If you're a human, you wouldn't see any of it. Your eyes aren't sensitive enough. But the giant squid's eyes are. Those massive dinner plate-sized eyes aren't just big for show. They're big because size directly correlates to light-gathering ability. The larger the lens, the more photons you can capture. The larger the retina, the more light-sensitive cells you can pack in. The giant squid's eyes have lenses the size of oranges. Behind those lenses sit retinas packed with light-sensitive cells in densities that exceed most vertebrate eyes. And unlike human eyes, which have a blind spot where the optic nerve connects, the giant squid's eyes are designed without that flaw, giving them clearer detection of faint light sources. But the real innovation is in how these eyes are tuned. They're optimized specifically for detecting the blue-green wavelengths that bioluminescence produces. This isn't an eye that sees the full spectrum of color. It's an eye designed for one purpose: detecting living things that are trying to hide in the darkness. Researchers who've studied these eyes using computer modeling have determined that a giant squid can probably see a sperm whale silhouetted against the faint light from the surface from over 400 feet away. That's 400 feet of advance warning that a predator is approaching. Enough distance to decide whether to flee or prepare for a fight. And in an environment where surprise is the difference between eating and being eaten, 400 feet of detection range is an overwhelming advantage. But vision alone isn't enough, because the deep ocean is three-dimensional in a way that surface environments aren't. Prey can come from above, below, in front, behind, from any angle in a sphere of water surrounding you. You can't just watch one direction and feel safe. This is where the giant squid's body structure becomes crucial. Those 8 arms and 2 tentacles aren't just weapons. They're sensory organs. Every inch of every arm is covered with sensors that detect chemical traces in the water, pressure changes from movement, even electrical fields generated by muscle contractions in other animals. This gives the giant squid a sense of its environment that extends in every direction simultaneously. It's like having 10 fingers that are each 20 to 30 feet long. All of them constantly tasting and touching and feeling the water. All of them feeding information back to a central brain that's processing input from a sphere of water over 60 feet in diameter. This is how the giant squid hunts. Not by chasing prey down like a shark. Not by lying in ambush like an anglerfish. But by hanging motionless in the water. Arms extended. Eyes watching for the faintest flash of bioluminescence. Sensors detecting the slightest chemical trace or pressure change that indicates something edible is nearby. And when it detects prey, those tentacles snap forward with explosive speed. Those suckers lock on with gripping force that can't be broken. And that beak tears into flesh with a cutting power that can wound animals 100 times its size. This is predation evolved for an alien world. A world of crushing pressure, freezing temperature, and absolute darkness. A world where the rules of surface hunting don't apply. Where size and speed matter less than sensory capability, and weapons that work in extreme conditions. And the giant squid has mastered this world so completely that it's become one of the most successful predators in the largest habitat on Earth. Because the deep ocean, the zone where giant squid live, makes up over 90% of the ocean's volume. It's the largest ecosystem on the planet, and the giant squid is one of its apex predators. But here's what makes the giant squid truly monstrous. What separates it from every other deep sea predator. It's not locked into the abyss. It's not confined to a single depth or a single hunting strategy. Giant squid have been found at the surface. They've been caught in fishing nets in shallow water. They've been filmed in areas that should be too warm, too bright, too far from their normal deep-sea habitat. This suggests something terrifying. The giant squid isn't just adapted to the deep. It's tolerant of a huge range of conditions, capable of moving through different zones of the ocean, hunting in areas where its prey would never expect to encounter a deep-sea predator. Imagine being a fish swimming at 300 feet depth, shallow enough that sunlight still penetrates, warm enough that you're comfortable, safe from the monsters of the deep. And then tentacles longer than your entire body shoot out of the darkness below you. Suckers lock onto your flesh with those rings of serrated teeth, and you're being dragged down into an abyss you can't survive. This is the reality of being prey in the ocean. The giant squid isn't confined to one zone. It's a monster that can appear anywhere, that can hunt in depths from the surface to over 3,000 feet down, that can adapt to different conditions and different prey with the same biological weapons that make it so effective in the deep. And we still don't know how big they can actually get. The largest giant squid ever measured was 43 feet long, caught near New Zealand in 2007. But that measurement includes the tentacles, which make up more than half the total length. The mantle, the main body of the squid, was only about 7 feet long. But here's the thing, that might not be close to maximum size, because almost every giant squid we've examined has been a juvenile or subadult. We've never found an old, fully mature giant squid at the peak of its growth. We know this because squid, like fish, have growth rings in their statoliths, small calcified structures in their heads that function like inner ears. You can count these rings like tree rings to determine age. And every giant squid that's been aged this way has been relatively young, usually under 5 years old. But giant squid are thought to live for at least 10 years, possibly longer. So where are the old ones? Where are the truly massive individuals that have been growing for a decade in the deep ocean, eating, and surviving and getting larger every year? We don't know. We've never found one, which means either they die young, which seems unlikely given how successful they are as predators, or they live in depths we haven't explored yet, or they're so good at avoiding detection that we've never managed to capture or film a fully mature adult. And if that's true, if there are giant squid out there that are significantly larger than anything we've measured, then the old sailor stories about squid attacking ships might not be as exaggerated as we thought. A squid with arms over 40 feet long and tentacles extending to 60 feet? That's an animal with a reach of over 100 feet when its tentacles are fully extended. That's an animal that could easily reach up and grab something on the surface from 50 feet below, that could wrap its arms around a small boat and capsize it, that could mistake the splash of an oar or the shadow of a hull for prey. We assume the old stories were myths because we've never documented a giant squid attacking a ship, but we've also never looked for them properly in their actual habitat. Almost everything we know about giant squid comes from dead specimens, washed up or caught accidentally. The 2012 footage was revolutionary precisely because it was the first time we'd ever seen one alive in the deep ocean where it actually lives. That's like trying to understand wolves by only examining roadkill and assuming that the absence of wolf attacks on cars means wolves are passive creatures. You're observing an animal in completely wrong context and drawing conclusions that might be dangerously inaccurate. The truth is, we still barely understand the giant squid. We don't know how they reproduce. We've never seen them mating. We don't know where they lay their eggs or how many offspring they produce. We don't know their full range or their population size or how they interact with each other. What we do know is this: the giant squid is an apex predator with weapons evolved specifically for killing in the most extreme environment on Earth. It has the tentacles that strike faster than most prey can react. It has suckers lined with teeth that create wounds just by gripping. It has a beak that can cut through flesh with over 1,000 pounds of force. It has eyes the size of dinner plates that can see in near total darkness. And it has sensory capabilities that let it detect prey from dozens of feet away in three-dimensional space. This is the true monster of the deep. Not because it attacks humans, it almost certainly doesn't. We're not part of its normal diet and encounters are vanishingly rare. But because it's an animal that evolution designed for lethality, that lives in a realm of crushing pressure and freezing darkness, that hunts with biological weapons so sophisticated they seem engineered rather than evolved. The giant squid proves that monsters don't need to be mythological. They exist. They're real. They're swimming through the deepest parts of the ocean right now, hanging motionless in the darkness with their arms extended, their massive eyes scanning for the faintest trace of bioluminescence, their tentacles coiled and ready to strike at anything unlucky enough to wander into range. And the most terrifying part? We've explored less than 5% of the deep ocean. We've mapped the surface of Mars in more detail than we've mapped the ocean floor. There are trenches and canyons and vast stretches of deep water that no human has ever observed. No camera has ever filmed. No robot has ever visited. The giant squid lives in that unexplored realm, and if there are larger ones out there, older ones, individuals at the peak of their size and power, they're existing in a world we've barely glimpsed. That's what makes the giant squid the true monster of the deep. Not the ones we found, but the ones we haven't. The ones still out there in the darkness, hunting with weapons that make them one of the most dangerous predators in the ocean. Living in an environment so vast and unexplored that they could be far more common, far larger, and far more capable than we currently believe. The monster isn't the myth. The monster is real. It's been real all along. We just never looked in the right place to see it hunting in its element, using tools that evolution spent millions of years perfecting, dominating an ecosystem that covers most of the planet. And every time a sperm whale surfaces with fresh circular scars covering its body, every time a fishing net comes up with tentacle fragments too large to match any squid we've documented, every time sonar detects something massive moving through water too deep for most animals to survive, we're reminded of a simple truth. The ocean has monsters. They're not supernatural. They're not imaginary. They're animals that evolved to survive and hunt in conditions that would kill almost anything else. And the giant squid, with its explosive tentacles and serrated suckers and razor-sharp beak, is the perfect example of what real monsters look like when evolution has millions of years to refine them. The sailors were right. The stories were true. We just weren't listening.